A very good evening to all. We are delighted to invite you all to an insightful webinar on an exciting topic, Mastering Piping Design Engineering, Unlock Your Career in the Oil and Gas Industry. Our trainer for today's webinar is Mr. Chandramohan. He's a mechanical lead engineer. He holds over 13 plus years of experience in the oil and gas, chemical, and petrochemical industries. He brings a wealth of knowledge and hands on expertise to our training program. As an accomplished mechanical engineer, he has successfully managed complex projects, including plant maintenance, new installations, and commissioning. His leadership in guiding teams of engineers and technicians ensures precision and efficiency in delivering projects to completion. His international experience includes significant roles in Malaysia and Kuwait, where he spearheaded chemical plant erections, maintenance strategies, and safety initiatives. His passion for safety innovation and fostering teamwork ensures an engaging and insightful learning experience. A warm welcome to you, sir.
Thank you, Samya.
So kindly take forward the webinar, sir.
Okay. I welcome everyone. Myself Chandramohan, and thank you for joining today's webinar on mastering piping design engineering. It is a continuation with our last session. So today, what we are going to see is to oversee of the overview of the modules that we are training topics which we are going to cover in upcoming sessions in detail. What we are going to see. So today I'm going to cover up just about all opportunities that is available in piping engineering, as well as the overall view of the training modules. As I explained last time, regarding the oil and industry, it is a critical sector that plays a main vital role in global economy. So in oil and gas industry, as you all know, there is a three major segments: upstream, midstream, and downstream. So upstream is nothing but exploration and extraction of the oil products. Midstream is just transportation and storage, transferring from one place to other place. Downstream is refining and breaking into uh, sub products and then supplying raw material to the other petrochemical plants. So these are all the main segments. Uh, Next one. So in upcoming our training modules, first one what we are going to see is PFD and P&ID. Some of you know about PFD and P&ID. PFD is nothing but a process flow diagram. P&ID is it's a piping and instrumentation diagram. So these are all the main thing that we are going to see in any field, not only in oil and gas industries, even in chemical, even in water treatment plant, sewage treatment plant, everywhere. P&ID plays a main role. It is like a bible for any process unit or any operational unit. So first, we are going to see process flow diagram. Process flow diagram is nothing but it is just a pictorial representation of the process. It is only showing a schematic diagram of the entire process unit or any utility unit. This will show only a major equipment only. It will not show each and every lines or any small lines and all. It will show only a major equipment only with its tag number and basic details. So and then it is design conditions and some instrumentation loop controls, everything only available in the PFD. All major equipments will be covered in the PFD. So on the other hand, in P&ID, so it is a detailed uh, form of process flow diagram which we will derive from the PFD only. In this P&ID, we will mention each and every valves in PFD where it is available only main isolation valves. That is, if it is a main controller like reactor, uh, inlet and outlet valves, means in P&ID we will cover each and every pump piping, even the drain lines, vent lines, drain valves, vent valves, pressure gauges, everything will be covered in the P&ID. So that P&D will be useful for to do the hazard study, everything before we put the plant into the operation, or even after the construction to cross check with the plan pipe routing, everything will be based on the P&D only. So there is a number of legends are there, uh, valve legends are there, instrument legends are there, that will be shown in the P&D. Okay, that these things and all we are going to see in very detail in the upcoming sessions. Okay, next one. Okay, this is the presentation of a simple process flow diagram. We can see where it is show only it is reactor, the upstream it is a exchanger, other than it's a vessel. So it will show only the major equipment. So if you go in P and AD in the same process unit, you will see a lot of instrument, a lot of valves, controlling devices, pressure transmitters, temperature transmitters, everything. So this is a PFD, and the next picture is the P and AD. Next picture. Next picture, Soumya. This is the PNAD, what we have discussed. So if you see this PNAD, you can see a lot of valves are shown here. Each and every nozzles in the equipments, even every nozzles in the pumps, equipment, static equipment, rotary equipment, everything will be shown in this PNAD. The top of the sheet, you can see the equipment detail. So with its tag number, operating condition, design condition, material of construction, so everything will be shown in the P&AD. So this is like a bible for any process unit. So okay, next one. Okay, before we get into piping in detail, piping modules in detail, I want to explain. I want to tell something about career opportunities. That is, there is different roles for a piping engineer in every plant or any project. So we have a variety of opportunities here as a piping engineer. First will be a piping design engineers. So majorly piping design engineers will do the entire routing for the any new plant or any modification, brownfield project or it is a greenfield project. Okay, his role is to design the entire piping layout or equipment layout, everything as per the set of codes and standards. So he will be dealing with the software such as E3D, SP3D, PDMS. These are all the 3D model softwares. So which we can see any clashes are there. So uh, any clashes with the other discipline or any other equipments, everything we can see in this software. So piping design engineer scope will be dealing with these softwares. Next one is project engineer. So that one we will discuss later, project engineer. So next third one is material science engineer. So it is also a part of piping field. He will be an experienced person who can knowledge in the particular in the material science. So his role will be initially at the early stage of the project. He will be focusing on the material selection along with the process engineers. So what are all the any if any other than the standard chemicals, other than standard fluids, if there any special chemicals is there, so what kind of material we can go with, everything will be decided for the material science engineer as per the codes and standards. Next is layout engineer. So he will be dealing with the overall layout of the plant, like overall plot plan, equipment plot, everything he will be taken care of with the help of process engineer as well as the piping engineer. Next is piping designer. So he will be working under the piping engineers. So they will be doing the overall piping drawings, who will be creating the equipment layout, isometrics, preparing the isometrics, checking the 3D as per the PNAD it is laid or not. So everything will be taken care from the piping designer. They will be dealing with mostly they will be dealing with the 2D and auto plant 3D. Next role is stress engineer. So a stress engineer role is to evaluate the structural integrity of entire piping system with considering the external loads and the forces acting on that any piping and connected equipments. So they will be using the majorly we are using the software for this stress analysis is Caesar 2 and CE pipe. So he plays a major role along with the piping engineer. And then technical sales engineer. So in other than the piping field, if you are producing any product like pumps, compressor, or any vessel, static equipment, what are all the we are manufacturing. So there will not be there will be a technical sales engineer who knows how to explain the product to the customer, or what it is, what MOC it is made up of, whatever it is, a rotary equipment or static equipment or any piping items like valves, pipes, fittings, any special items like bellows, strainers, everything. So he will be the who will explain to the customer, or who be explained to the client. He will be the technical sales engineer, and then technical procurement engineer. So these are all coming under the mechanical engineer, particularly under the piping engineer role. So based on the experience, so if you get more experience, they will be promoted to like a project engineer or project manager, like that. So in this technical procurement engineer is, so in any large scale projects, so there will be, definitely there will be a procurement person, but they should not know bargaining with the products. They also should see the quality and the standard. So definitely a mechanical engineer or a piping engineer will be the procurement engineer in large scale projects. And then finally inspection and testing engineer. So he will be dealing with the quality, uh, whether the welding is made as per the standard or not, whether the piping that we going to use into the uh, fabrication, it is no, it is compliant with our PMS or not. Those are all will be those details and all will be checked by the our testing engineer or QA engineer, we call it series. Next series. Finally, it is a project manager. So he will be the overall responsibility to deliver the engine, whatever it is, the engineering or procurement or any construction work or any commissioning work, everything will be comes under the project manager. Why I'm here wanted to highlight project manager means, so we any project, any large scale project, medium scale project, there will be a number of various discipline will be working in the project, like instrument engineer, electrical, or a process engineer. But if you see the project manager, he will be from the, mostly he will be from the piping department or mechanical department. So means, as a mechanical engineer, we only easily can understand the practical difficulties. So we only dealing with the, because we are going to deal with the process engineer also, we are going to deal with the civil engineer also. So our equipment is mounted on their foundation, so there also we have to discuss with the civil engineer. Whereas in instrument part, they have no any relate between the civil engineer. So we will be the mostly piping engineer, mechanical engineer will be the coordination. We will be do the coordination work. So in any project, if you see that project manager, he will be from the I mean, mechanical background or a piping background, just because we will be doing the overall layout in the piping GA. So electrical and instrumentation will follow our routing only. So in any cost wise also, our cost will be going very high, piping cost and other equipment cost. So everything will be no, mostly we other disciplines are depend on the mechanical person or any piping person. Okay, next. So these are all the now what we are going to see is what are all the training modules or training sessions that we are going to see in upcoming sessions, like January 25th onwards. So this is the first topic, I think, in piping, apart from the PNAD and PFD. What we are going to see is fundamentals of piping system and pipe sizing with its material selection. So as you know, piping is nothing but a combination of or compiling of pipes and other fittings, everything. So what we are going to see in this module is how we are designing the piping system, and how we are choosing the pipes based on material or its sizes. So how we are selecting the sizes for a particular system, and how we are selecting the piping material for the select particular system based on its pressure or temperature or handling liquid. Those and all we are going to discuss in this topic. So mostly piping sizing will be done by the process team along with the piping. So based on software like pipenet, everything. So on piping material selection, we will have our own manual calculation and all that, and all we will show in detailed sessions how we are selecting the material, how we are selecting the pipe size, everything and all we will see in detail in those sessions. Okay, next one. Next session will be piping codes and standards. That is lot of piping codes and standards that we need to follow while designing anything, even a static equipment, rotary equipment, or doing a piping GA, general arrangement drawing of piping, or doing the isometric. Everything we have some set of codes. Mostly we are following here American standards, mostly ASME 31.1 as well know for power piping, 31.3 for process piping in the refineries, and then ASTM standard, American Society of Testing and Materials. So yeah, like API code for API 650 for welding tanks, API 560 for heaters. So like the 60 for heat exchange, like this API code, ASME code, ANSI code, ASTM. So these are all the codes we are mainly following in our oil and gas industries and petrochemical industries. So what are all the code applicable to which equipment? So how we are at what stage we have to refer these piping codes while designing the plant. Everything we will be seeing in that session. Next, Soumya. As I said, here, next topic will be in piping material specifications and thickness calculations. So piping material specification is nothing but PMS. For any project after the PNAD. So once PFD is freeze, next we'll come to PNAD after the HACCP everything completed. Next, our job is to prepare the plot plan, as well as this plot plan will be taken by the civil and mechanical person together, and other part we have to focus on the PMS like piping material specification. So there is lot of materials are there, so which product we have, which material we have to choose for which product. So this will be a bible, like how PND is a bible for the process engineers, like PMS is a bible for the particular project. I'm telling you the particular project only PMS is applicable until the completion of the project. So any stage, at any stage when doing fabrication or doing commissioning, everything we have to cross check with the uh, PMS, like nothing but piping material specification, and the VMS, valve material specification is there. While procuring any product related to, I mean, not any product related to the piping, we have to refer this PMS, and then we have to check the quality of the product along with this PMS only. So in this PMS, everything will be shown. So there will be a piping code, piping index number for each and every pipeline. Let's say we are going to deal with the water, steam, like oil. So everywhere there will be for water there will be a separate code in PMS, and then for a steam line based on the temperature we will be naming different. Like example, if you are dealing with the corrosive products, we will say SS. Like steam lines, we will say carbon steel, CS. So in steam itself there will be a different temperature will be there, like pressure will be there. 6 bar will be there, 60 bar also will be there. So in that case we will say CS1. For 60 bar we should use CS2. So what will the difference is that pipe schedule, and then how we have to take the tapping from the parent material and any image header, how we have to take the tapping. So what are all the testing standards, everything will be shown in the PMS. On the other hand, wall thickness, this is only about the material. So for steam also it will be carbon steel. For water also it will be carbon steel. So what grade and what are all the thickness? Thickness is nothing but pipe schedule. So how we have to we are going to select the schedule. Everything will be based on this wall thickness calculation. We have our formula is there, thickness to find out the thickness, like PD by 2 AC. P is the pressure, D is the outer diameter, and S is the allowable stress, and E is nothing but the welding joint efficiency. So there is a code book in ASTM. It has given a code book, and standards we have given. One second. Am I audible, Soumya now? Okay, sorry. Uh, okay, wall thickness calculation. So we are having a manual calculation which is derived from the code book. So how we are deriving the calculation for how we are adjusting the allowances, like manufacturing tolerance is there, corrosion allowance is there, threading allowance is there. So these are all the allowance which we need to consider in the while selecting the material. For example, for steam line we are going to choose a schedule 80 pipe. The thickness will be like 6 mm to 8 mm, like for any pipes. for some particular sizes. So in that, what are all the method we are going to join the pipe? If it is a flange joint, or we are going to join with a thread joint. For instrument pipes and all, it will be coming a threaded joint. So in that case, we have to uh, derive from this formula. So how much thickness is required for that instrument line? So based on the pressure, based on the temperature, based on the stress value. So stress values and are given in the code book. So that we will no explain you in detail, like a sample calculation also we will show in upcoming sessions how we are deriving a thickness. Okay, next slide, Soumya. Piping components and okay, this is a manufacturing. So it's nothing but okay, it's a piping type, seamless pipe, seam pipe, we will say welded pipe or seam pipe, and the casting items. Seamless pipe is first one we are showing, this is a seamless pipe. That means there will not be any no joining symptoms. So there will be it is produced by a piercing a heated material and elongating into a some sizes based on the, it will be from 1 inch to 12 inch, mostly from 1 inch, from half an inch to 12 inch we will be using this kind of seamless pipe, that is particularly for corrosive product or any petrochemical plant, a petrochemical product, we will be using the seamless pipe. Second one you are seeing is the longitudinally welded pipe, that is a seam pipe. It will be used for the low critical pipelines like air lines, water lines, utility lines, sewage pipelines. For these pipes and all, we will be using the uh, welded pipes. And the cast pipe, this is the last one, is also a welded pipe, that is a spiral weld. That is mostly will be used for the higher pipe sizes like 16 inch, 18 inch, 20 inch and all. We will be using these spiral welded pipes. Cast iron means, it's a casting means nothing but a cast iron pipes. So that also we will be seeing in upcoming module. Next one, Soumya. Uh, this module is we are going to see piping component and valves. So this session we are going to see various components of piping systems, including some major fittings, flanges, supports, and its valves. What are all the types? Everything we will be seeing in the piping component. So on what basis we are selecting the piping component? What are the selection criteria for this? What are the application of these fittings to any process systems? Those and all will be seen in this module. First, you see pipes and tubes. It is in piping component. Pipes is a major one. It is a hollow cylinder available in various material like what we discussed in carbon steel, stainless steel, casting pipes, HDPE pipes, plastic pipes. Everything it is available. So that one all we will be seeing in detail. So how we are manufacturing the pipes, how we are selecting the pipes, how and on what for what service, which pipe we are selecting, seam pipe or seamless, or what sizes we are selecting based on the flow and the pressure. Everything we will be seeing in that section. Fittings is combination of nothing but common name. It's a combination of elbows, tees, reducers, coupling, the caps, screws, plugs. Everything will be comes under the fitting. So in this picture you can see that is a elbow. So it will be majorly used in the direction of flow from 90 degree to 45 degree or 90 degree to 0 degree. Everything and all will be done by the elbows. T's we will be used in the create a branch in the any piping system to tie in or tap off. Everything will be done by the T. That also will be explained in the PMS. So in which service we have to use the ready-made T, and which service we can take the tapping. Everything will be we will be seeing that upcoming sessions. And the reducer, coupling is nothing but to join a pipes. There is two types to join the pipe. One major variety of types is there. Majorly we will use the flanges and the couplings and the some threaded sometimes for any whichever whatever the material we are not going, we cannot be welded like uh, plastics or GI pipes and all. We will be using the threaded joint. Flanges, these are used to connect the pipes with the other components, like a pipe we are going to have to connect with the pumps, or pipe we have to connect with the any compressor, which we will be take no, which is require maintenance. Pumps we have to take out for the maintenance, so we cannot weld the pipe with the uh, weld the pump nozzle with the pipes. So we need a flange joint, or wherever the maintenance is required, wherever we expect a no choke in the pipelines, if it is handling the semi-solid pipes, it is required frequent maintenance or cleaning of the pipes. So those areas and all we will be using the flanges. There is also different types of flanges are there according to the services that we will be seeing later. Gaskets also we will see that is used to it is a gas prevent the static leakage between the flanges to pipes or flanges to flanges. Strainer is, as you know, it is used to remove the uh, solid particles from the system. Particularly, we will be using in the upstream of, I mean, suction line of compressors or pumps or any major static equipments, inlet lines. And then supports those these supports. Okay, in piping system that we will be seeing in future. This is not the component, but it will be a part of a piping system. Okay, next, Soumya. Like what we discussed, these are the different types of valves are there that we will be see. It's a gate valve. This will be used for on-off control only. There is a different type of uh, full bore, half bore. Those valves are trim. How we are, selecting the gate valve with the trim sizes, everything we will be seeing. Globe valves. This majorly used for the throttling the flow. Majorly we will be using in the bypass. So if you are going to by control valve will be there. It's a flow control valve. So there will be a bypass arrangement. So in this bypass arrangement, we will be mostly 99% we will be using the globe valve. Why? Because it is based on its construction. So gate valve will be different. Internal trim will be different. In globe valve, it will be different. So that's why we are majorly global will be used in the throttling process or controlling process. We will see, and then check valves. So these valve is nothing but non-return valve as a technical name. Non-return valve. It will allow the flow in only one direction only to prevent the backflow. Particularly, we will be using in the pump discharge lines or compressor discharge lines. We will be using these non-return valves. There is a lot of different types of non-return valves are there. Piston valve, wafer type, butterfly type. So those and all we will be seeing in detail. So based on the services, what type of valve we have to choose. If it is a semi-solid service, what type of NRV we have to choose. Same like gate valve and globe valve and all. Where we have to choose the flange valve, where we have to go for welded valve, where we have to go for screwed valve. Everything we will be seeing in the detailed schedule when we are discuss about the piping components and valve modules. Next is ball valve. Same like I explained before. uh, Ball valves, butterfly valves, mostly ball valves and butterfly valves and all. We will be seeing the higher flow rate, like valves and like water, air. Those will be handling the major flow. So in those areas, we will be using the butterfly valves, and where we will be using the plug valves, where the tight shut off required. So those area where Q control is required, those kind of areas are we will be using the plug valves, butterfly valves, and then pressure relief valves. It's nothing but the PRV and the PSV, TSV. So in which system we have to use the PRV, how we are selecting the PRV, those things and all we'll be seeing in the upcoming schedules. Next, Soumya. This is a pictorial of a valves. First one we are seeing the gate valve. From seeing the from seeing the picture itself, we can able to identify which one is gate valve, which one is globe valve. So how we can identify that and all I will explain in the detailed session. So check valve is there, needle valve is there. Needle valve mostly we will be using in the sampling point where we're taking the sample. Where it is be useful for the tight shut off. At the same time, we will be using in the sampling point. Ball wall is a relief valve you are seeing. Piston valves is there. Diaphragm valve, it is also a kind of valve used in the water services where we are expecting the more corrosive or clean liquid. So in those kind of areas and all we will be going for the diaphragm valve. So I will explain later. Next to me, piping supports. It will be a next session. uh, Next module is a piping supports. What are all the types or the no, type of supports are there. So primary support, mostly it will be primary support and secondary support. Primary support will be welded to the pipe or fixed to the pipe permanently. Secondary pipe is which is supporting the pipes, like a pipe rack. A pipe rack is a secondary support, and the shoe support will be the primary support which is welded to the pipe. So the major uh, different is there, pipe support. So what is the use of pipe support is it is used to safeguard the pipes from sagging or any misalignment due to the weight of the products or due to which the uh, weight of the fluid which it is carries, and then to accommodate the thermal expansions whenever contraction and expansion we are expecting, like steam lines and high temperature service lines. It also not only to support the pipes, but also it is used to minimize the vibrations while in the operation, and for structural integrity, and also to keep the stress value of the piping components within the limit. For these I will explain later regarding the pipe support. It is a big subject, we'll be seeing in detail. Next one. These are all the major pipe support. First we can see is a clamp support, lug support, shoe support is there. Mostly where we are using the insulation or hard service or high temperature service, we will be go for pipe shoe. Saddle support, last one you are seeing, that is a saddle support. That is a support we will be using in the static equipment mostly. Heat exchanger or horizontal vessels, we will be using the saddle support. And then hanger is nothing but a spring support. There will be different types of spring supports are there, we will be discuss those things. And then anchor point, a guide, rest support. These are all the types of the majority type of the support. Rest support will be, it will not guide the pipe, it will just hold the weight of the pipe. If it is a guided support means it will guide the pipe in one direction. So we will give some gap between the pipe and support, mostly it will be 3 mm, so it will allow the pipe to move only 3 mm only. These are this side. So apart from after that it will not allow the pipe to move. So wherever we are expecting the more thermal expansion, so more movement in pipe or more vibration we are expecting, so in those areas we will be go for the guide support. Three dimensional no arresting support is there, like limit support, spring hanger suspended support, trunnion support. So there are different supports are there, we will be seeing detail. Next, Soumya. Okay, these are all the main thing. Various piping softwares we are using in the piping field, particularly in oil and gas field. So majorly we are using the AutoCAD. It is like I explained earlier. So AutoCAD we will be using for preparing the piping layout, and then extracting the isometrics. So these will be done in the AutoCAD software. See, second one is Caesar 2. This is mainly we are using for the stress analysis. To evaluate the pipeline stresses, we are using this software. And then Plan 3D, like I explained earlier, E3D, Plan 3D, PDMS. So these are all 3D model software. We'll be using the design the whole entire plant, like E&I, civil, uh, mechanical, piping, everything will be, we will be designing the 3D model. So we will be seeing these softwares in detail. So which software is used for, mostly widely used for which job, everything will be in discuss in detail. Next, so yeah. Stress analysis, yes. This is a very very important subject in piping engineering. So why we need to do piping stress analysis is to uh, evaluating the forces and stresses acting on the piping system. So what is the purpose of this stress analysis? To it is to ensure the safety and the efficiency and reliability of the piping system. We will be using some codes and standards for this, like ASME 31.3, and some allowable nozzle flows from getting from the manufacturer. Everything we will be consider while design while doing this stress analysis. And then material, what is material is made up of. So what is the standard of the pipe flanges? Everything we will be seeing the pipe stress analysis. Pipe stress analysis is very very important in piping engineering again and again. Why I'm telling this one is, recently we did one project, we have completed everything in that like general arrangement, isometrics, everything we have completed. But when we going for execution, we gone for execution, at that time we have found the kind side, we have found no that connecting equipment is made up of some other material which is not allowing our our pipe to connect. It is nozzle allowable load is very low compared with the API code. So generally we will follow the API 610 for the pumps, centrifugal pumps. So in that case, it is a special pump made up of different MOC other than carbon steel. So there we have faced major issue. Then the client simply didn't accept our general arrangement and isometric drawings. Again, we have to come for the stress analysis. We have done rework on stress analysis. We bring back the allowable limit within the manufacturer code. Then we clear that project. So whatever it is, we gone for general arrangement, gone for isometrics, or even if we done the fabrication. So no, before that we should check, we should pass the stress analysis. So after preparing the basic general arrangement drawing, we have to do the stress analysis whether it is um, passing our code, everything is under and all. We have to check with the stress analysis. Then only we will go for the final general arrangement. Then only we go for isometric drawing. Okay, with that we will explain. We will show in stress analysis module. We will show a sample calculation. So how we are, making the module, sorry, models. How we are, selecting the supports based on the load. So on what are all the checkpoints we are having, like flange check, nozzle check, flange leak check, stress displacement, seismic loads. Everything we will be explaining in that, showing that stress analysis to software. We will explain with sample. A model in that particular session. Next, Soumya. Uh, so so these are all the roles and the responsibilities of a piping engineer in particularly in oil and gas industries. So our role will be preparing the whole plant setup and layout, equipment, preparing the equipment layout, and then preparing the piping GA, selecting the material, and selecting the piping support according to the services, and then to do a 3D modeling for the overall project, and then preparing the fabrication drawings in isometric way. So these are all comes under the piping engineer scope, particularly in any oil and gas, not only oil and gas field, any chemical or petrochemical plant. So these are all the modules that we are going to discuss in upcoming sessions. So this is just I just explain about what we are going to discuss. Okay, thank you. That's it from my side.
Thank you very much, sir, for taking your valuable time and taking this excellent session. And I hope this would benefit all the engineers. So attendees, if you have any questions, you could post your doubts in the comment section. And I would like to give a small information. The program is from 25th Jan. It will be conducted on weekends from 10 a.m. to 1 p.m. IST. So you can find the registration details in our LinkedIn Step in Engineering's LinkedIn group. So you could register yourself, and you could also refer your friends. And for students, you have a 50% discount. If you're going to register before 11th, like if you're going to proceed with if you're going to do the payment, you'll be getting 50% discount. And the discount ends on 11th Jan. So kindly make use of this wonderful opportunity. So if you have any queries, you could post your queries in the comment section. Okay, sir, we can wind up the session. Thank you very much, sir, and thank you all the attendees once again.
Thank you all.